let's look at the law of logs. So if a and b are both positive, then the log of a times b is equal to the log of a plus the log of b. So you can split them up with addition. If you have the log of a divided by b, that's going to be the log of a minus the log of b. Okay, and so anything that's in that denominator would get a minus the log of that. And then log of b to the t, this is going to turn out to be a really useful property here. You can bring this t down in front, okay, so that exponent can come down in front and you get t times the log of b. All right, so let's try these out. We're going to do 16, 17, and 18 here. So this is the log of 6 times 11, and we could certainly just multiply that and say it's the log of 66. But to practice this rule, I want to show you that this could be written as the log of 6 plus the log of 11. Okay. And the log of 1 over 4, we'll use this rule here. So I have the log of 1 minus the log of 4. And then the log of 3 to the 5th here, I can bring that 5 down in front using this property here. So I get 5 times the log of 3. All right, so I bet you know what's coming. I would love for you to pause this video and try 19, 20, and 21 on your own. Make sure you feel comfortable with this. All right, so let's see how you did. So log of 3 times x, I can write that as the log of 3 plus the log of x. The log of x divided by y is the log of x minus the log of y. And the log of x to the 4th, I can bring the 4 down around in front. So it gives me 4 times the log of x. All right, so now that we've got a good handle on those, 22, 23, 24, 25 are going to combine several of these rules together. So let's try some of these. Log of x to the 5th divided by y. So one of the things I can do right off the bat is split it into the log of x to the 5th minus the log of y. So I applied that division rule first because that was kind of the big piece there that was holding it together. And then I could bring this 5 down in front. So this is 5 times the log of x minus the log of y. Let's look at 23. So I have the log of AB over C. So that division, again, is kind of the big thing that's going on there. So I'll take care of that first by doing the log of AB minus the log of C. And then this is as simple as it can get. There's no exponent or anything else going on here, but this one has some multiplication. So I can split that up using addition. That would be the log of A plus the log of B minus the log of C. All right, so 24 is combining some of the things from this one and some of the things from this one. So let's tackle that. I'll break it up into a couple pieces and then I'll explain kind of a way you can shortcut this as you're feeling more comfortable with the rules. So again, the division is kind of the big thing there. So I'll do log of AB squared minus log of XY. And that gives me the log of A plus the log of B squared minus the log of X. And this minus gets distributed to both of these. So if I have minus the log of XY, it'll be minus the log of X minus the log of Y also. And then I can bring this 2 down in front here. And so I end up with log of A plus 2 log of B minus log of X minus log of Y. And kind of another way, as you're feeling more comfortable with these, is to kind of break them into pieces. So I have an A and a B squared, I have an X, and I have a Y. And anything in the numerator is going to get a positive sign or a plus sign in front of it. Anything in the denominator gives me a minus sign. And the thing to watch out for is what letter exactly that exponent goes with, because that 2 only goes with the B and not the A. So kind of keeping that in mind, I can look at that and say, okay, log of A is in the top, so that'll be positive. You see a B squared in the top, so I get a plus, and B squared would be 2 log B. x is in the denominator, so minus the log x, and then y is in the denominator, so minus the log y. All right, so I'm going to try that out with this one here and see if I can kind of shortcut it a little bit. Feel free to write out all the steps if you need to, or as you become more comfortable, you'll kind of develop some of your own shortcuts here. So I see a 10 to the 4th and a b squared in the top. So that looks to me like I have log of 10 to the 4th. And then b squared, so plus 2 log b. And then in the denominator, I see that 10. So I'll say minus the log of 10. And I see the x by itself, so minus that log of x. Then also in the denominator, I have this y to the 5th. So minus 5 log y. And then there's still a little bit more I can do here. So that's these two here that have the numbers with them. So log and 10 are those inverse functions. So this thing here is really equal to 4. And log of 10, that's just equal to 1. There's that imaginary 1 there. You can use the property that we have up here in this table. And so that looks to me like this is going to be a minus 1. So 4 minus 1 will simplify to 3. And then I'll just write the rest down. Plus 2 log b minus log x minus 5 log y. So that would be as expanded as you can really do that one.